Okay, we're going to calculate the relative atomic mass of atoms here. Now, definition of a relative atomic mass, AR, is the mass of an average atom divided by the mass of carbon-12 nucleus multiplied by 12. So I think that's the best way of defining it. You can define it purely, in prose, but I think it's easier to do it that way. What's that saying? Is you're saying that, all right, say let a carbon-12 nucleus weigh 12 units, and the mass of all other atoms are given relative to that. So you're saying carbon-12 weighs 12, compare everything else to that. Now you might think, well, it's stupid, why don't they just say, right, let's look at, let's let hydrogen weigh 1 and compare everything to that. Well, I think technically the reason why they don't do that is because not all protons weigh the same as each other, depending on nuclear binding energies. And the proton in a hydrogen nucleus is unusually heavy. It's a bit heavier than any other proton, so that's why they don't use hydrogen. And they use carbon because the sort of nucleons in carbon-12 are a sort of fairly average value. Anyway, don't worry about that. Now, what's this bit here mean? Of an average atom. What's an average atom? That means, okay, taking into account how abundant each isotope is. Okay, so let's have a look at an example then. And the example we're going to use is magnesium, and this really is they do ask these questions on GCSE, so this is not that difficult, but we'll do it anyway. Right, so magnesium is made up of 3 isotopes: 24, 25. It's got another neutron, and magnesium 26. Okay, and the percentages of those are, well, magnesium 24 is 79.0%. Magnesium, that one is 10%, 10.0%, and this one is 11.0%. Okay, so we're going to calculate the relative atomic mass. So what I'm going to say is in 100 atoms, well, we're going to have, choose 100 atoms at random, you're going to have 79 magnesium 24s. You're going to have 10 magnesium 25s, and you're going to have 11 of the 26 isotope. Right, that's 100 atoms, so let's work out the masses of those. So 79 times 24 79 times 24, that's 1,896. This one is 10 times 25, that's 250. And 11 times 26, that's 286. So I'm going to add all that up, and that is going to come to 2,432. That's the mass of 100 atoms. So therefore, the mass of an average atom is going to be equal to that divided by 100. That's equal to 24.32. So they're 3 significance figures. I'm going to say the AR of magnesium is 24.3. Okay. So that's how we do that. Now, you probably would write that down. Instead of using these percentages, it's what you can, and for the next step, it's a bit easier to do than this. I would probably say, so the AR is going to be, so instead of using a percentage, 79%, that's like 0.79, isn't it? So I'm going to do 0.79 times 24. So that's how much the 24s are going to weigh, plus 0.1, 10% over 100, yeah, is 0.1 times 25, plus 0.11, that's 11% times 26. Work all that out, and it comes to 24.32. So it's just, instead of using percentages, we're using these fractions, okay? Right. They seem to, in recent years, they seem to think that's a bit too easy for AS, and so they don't ask it very often. What they do is they try to get you to work it out backwards, and we'll do one of those. So they'll say, for example, the AR of lithium, so the AR of lithium, and that is given to right, okay, is given as 6.94. Okay, lithium is a mixture of lithium 6 and lithium 7, and so you've got to calculate the percentage of each isotope. So we're doing it backwards. Now you can tell by looking at this, first of all, look, it's 6.94, so it's going to be mostly the lithium 7 with a little bit of that one. Okay, so let us say let the abundance of the 6, let's that equal to X. Okay, now total abundance that's got to be equal to 1. The fraction of everything together is 100% 1. So that means, so therefore, the abundance of 7 has got to be equal to 1 minus X. So now let's basically do what we did here. So we're going to say the AR is equal to right, 6, the mass of the isotope number 6 times by its abundant, which is X, plus the mass of the isotope 7, which is 7, multiplied by the abundance of that, which is 1 minus X. They tell us what AR is, the 6.494. So 6.94 is equal to 6X plus 7, 1 minus X. Let's multiply that out. So 6.94 is equal to 6X plus 7 minus 7X. So therefore we're going to just simplify that out. We're going to get 6.94 is equal to 7 minus X. 6X minus 7X is minus X, yeah. So that means then X is equal to 7 minus 6.94, which is equal to 0.06. What is X? Is the abundance of the numbers of the isotope 6. So that's equal to 0.06, which is equal to 6%, or 6.0%, I should say. So we can say from that, therefore, the abundance of 7 has got to be 100% minus 6, which is equal to 94%. Okay, so working it out backwards seems to be more that what they ask because it's a bit harder than working it out forwards. So make sure you can do that.